So when we did small sample confidence intervals, we had problems where we had to calculate the mean and standard deviation on our own before constructing the interval. So we're going to do the same with hypothesis test here. Now before I do that, I want to emphasize that you're going to use t-values whenever your sample is less than 30. And so usually these problems where we have to calculate the mean and standard deviation, the sample size is less than 30. Okay? And so you'll be using t-values in that case. But there could be problems where we're not calculating the mean and standard deviation. So like the ones that we did in the previous video here with the bookstore, this looks just like a regular hypothesis test problem, okay? But you need to be on the lookout for sample size, and always check out the sample size. And then if it's less than 30, you need to use critical t-values and not critical z-values. So one reason I did Chapter 8 homework all in one is so that I could mix those up together, and that way you'll have to be, as you're doing the homework, you'll have to be paying attention to when you need to use the critical z-value or the critical t-value. And so be on the lookout for that. So now let's try one where we have to calculate the mean and standard deviation on our own here. So in this case, a psychologist has prepared an optimism assessment to be administered to graduating seniors. So this is like some sort of questionnaire or test or whatever that's going to try to measure how optimistic the graduating seniors are. Okay, so 5 years ago the average score was 15, and it is suspected that optimism has decreased since then. So to test this, a sample of graduating seniors are given the exam and they receive the following scores. Okay, so we want to test at alpha equals 0.05 whether the average test score has decreased. Okay, so to do this, I gotta first find the mean and standard deviation. Okay, so we're gonna start by getting the sums. So my n here is 10. I'm going to use my calculator to get the sums. So I'm going to clear it. I'm going to pick SD mode for statistical data, and now I'm going to type these values in. Okay, so 7, m plus 12, m plus 11, m plus 15, m plus 6, m plus 8, m plus 8, m plus 13, m plus 9, m plus 10, m plus. Okay, so what I get here, so shift 1, and what I get here for the sum of x is 99. And then what I get for the sum of x squared is 1053. Okay, so now I can use these to get my mean and standard deviation. So the mean is going to be 1053 divided by 10. And that's going to be 10.5. And I'm going to round these to the nearest tenths place. Okay? And so, nope, I did this wrong. I am sorry. My mistake here. What did I do wrong? I used the sum of x squared, okay? So, this is really 99 divided by 10, and that's approximately 9.9. And I'm going to round to the tenths place here. If I have to round, I'm going to round to the tenths place. Okay, so that's my mean. Now my standard deviation is going to be the sum of x squared minus the sum of x quantity squared divided by n, all over n minus 1, and then I can take the square root of that. Okay, and then I get my standard deviation. So 1053 minus 99 squared divided by 10. That's my top. I'm going to divide that by 9. That would be the variance. Take the square root, and that would be my standard deviation. 2.8. I'm going to round to the tenths place. 2.8. Okay? So that now I got my mean and standard deviation, so now I can perform the test. So the question is, what is the hypothesized mean in this case? Okay, do you see what it is when you look through that? Okay, this is, when I calculate it, that's a sample mean. So the hypothesized mean is what it was 5 years ago, so that's given in the problem. Okay, and so I'm going to assume there is no difference. I'm going to assume that the true mean is equal to the hypothesized mean, and then I want to show, has this decreased? True mean less than the hypothesized mean. Okay, so that makes this a left-tailed test. So this would be 0. And so I shade in my left tail. I'm going to do this at 0.05, alpha equals 0.05 significance level. And then my degree of freedom is going to be 10 minus 1, so it's 9. And so what I'm going to do is I'm going to go to my t-table. This is a one-tailed alpha, 0.05, 9 degrees of freedom. And my critical t-value is 1.833. So this is 1.833. And since it's a left-tailed test, I need a negative sign. And so now, to reject H0, my test statistic has to be below negative 1.833. So now I'm going to calculate my test statistic. So this is step 2. Maybe I'll do step 3 here. So my sample mean is what I calculated, 9.9, minus the hypothesized mean, which is 15, divided by this standard deviation, 2.8, over the square root of 10. My sample size is 10. Okay, so now 9.9 minus 10. 9.9 minus 15, and then I'm going to divide this by 2.8 divided by the square root of 10. Okay, all that's in parentheses. Hit equals, and look what I get, negative 5.76. So this is approximately negative 5.76. That test statistic is huge. It would be like way over here. Okay? And so we're definitely going to reject H0. And that means there is enough evidence to conclude the true mean score has decreased. Okay, and if we think about the type 1, type 2 errors, okay, the type 1 error would be concluding that it's decreased when it really hasn't. Okay, but look at my test statistic. Oh, and you know what? I said Z here. This should be T. This should be T. Okay, my test statistic is way into the rejection region. So I really have more than enough evidence. This is kind of like, this is what you really like to see when you're performing a test, because then you know for sure you have enough evidence to reject. And in this case, I do. Okay? So there you go. That's the hypothesis test from beginning to end, where you're given the data, and then you have to calculate mean, standard deviation, set up your test and perform it, and then interpret the results. So in the next video, I'm going to give you one to try, and then we're going to be done with Chapter 8.